Hi everyone. Today we're talking about John Searle's so-called Chinese room argument, which he presents in this paper called Can Computers Think? So some basic points that we're going to cover in this brief lecture is the difference between strong and weak artificial intelligence, the difference between syntax and semantics. We're going to question the nature of genuine thinking, and we're going to look at Searle's argument as to why computers cannot think, in his view. So in the background here, we have the so-called mind-body problem. And this is just a question about what the exact relation is between the mind and the body. So the body is the physical thing that we all have, and the mind is our capacity for thought. So consciousness, imagination, perception, knowing, believing, remembering, fearing, all of these sort of mental states that you can be in. The question is, how do those mental states relate to the body? There's three broad families of views that we might consider here. First is physicalism, which is the idea that ultimately the mind is something physical, so that, for example, mental states just are brain states. We have dualism, which you see in figures like Descartes, possibly Plato, and in quite a few different religious traditions. And here the idea is that the mind and the body are two separate things or substances. So the body would be something physical, and the mind on this view would be like a soul, which would be a non-physical entity that is responsible for thinking. And finally, what is sometimes called dual aspect theory, which is the idea that the body, in particular the brain, is fundamental. So the physical thing comes first, but somehow that physical thing gives rise to a non-physical series of mental events. So the idea would be that the mind is an aspect of the body. So somehow something that the brain does on this last view would produce non-physical mental phenomena. So the reason this doesn't count as physicalism is because it takes the mind to be something non-physical, but it's not dualism either, because the dual aspect theorist thinks that the mind is ultimately dependent upon the brain, even though the mind is not itself a physical thing. So there's a lot to say about that. That's just in the background here. We're not going to get into the details of the mind-body problem, but just want to point out that if physicalism is true, some people have thought that maybe the way to explain the mind is to think of it as if it were a kind of computer program running on hardware, where that hardware just is the brain. So if a view like this is correct, that would mean that minds don't have to be biological. It just so happens to be that our minds depend upon our biology, our brains. But it would be possible on this view to construct an artificial mind. So to build some sort of non-biological artifact, so a computer in Searle's case, that would engage in the activity of thinking, which, if the physicalist is right, is ultimately a physical phenomenon. So this leads to the question of whether you can have such a thing as artificial intelligence. Of course, we use the term, we refer to some things as being AI, but Searle wants to question whether they really are intelligent in ways that matter. So we can distinguish between strong and weak AI. So you might think of strong AI as an artificial intelligence that's at least equivalent to what a normal human intelligence can do. So that would include things like understanding and learning. You might ask, are so-called large language models that are so popular today, are those examples of strong AI? If yes, you might say, well, the mind is to the brain for us as a program, an artificial intelligence program, is to the hardware that's running it. So the supercomputers, right, that are running somewhere on a network, just like the brain gives rise to the mind, so those supercomputers give rise to strong artificial intelligence. That's one possible view. It's going to be a view that Searle rejects, but just laying out possible views at this point. On the other hand, so-called weak artificial intelligence would be an intelligence that simply mimics what human beings do, but lacks real understanding, learning, and so on. So sometimes, for example, we talk about the artificial intelligence of non-playable characters in video games. In that case, they're just following scripts. They're just programmed to act in a certain way to give the illusion of an intelligent being. but nobody really thinks that those sorts of non-playable characters are actually intelligent in the same way that humans are. So the question is, it seems pretty obvious that we do have weak AI, but the question is, do we have strong AI as we've defined here? And if not, would it ever be possible that someday we could perhaps build one, or that some other civilization could build one? Well, Searle engages in a thought experiment called the Chinese Room, in which he uses to make the case that strong artificial intelligence is not possible, at least for computers and their programs as we currently understand them. So the Chinese Room is a so-called thought experiment. In general, thought experiments are cases that we can think about in order to test ideas. So often they're imaginary and unrealistic. That's okay. The point of them isn't to be realistic. Rather, it is to imagine a possible scenario in order to test our intuitions, to test our beliefs, our responses, what seems plausible in the context of this imaginary scenario. So it's literally an experiment that you carry out in your own thought. So examples of this, philosophers use these all the time, but not only philosophers. So so-called trolley problems, whether you should pull a switch to divert a trolley from running over 5 people so that it only runs over 1 person, and many variants of that. People debate the ethics of situations like that and find trolley problems arguably to be a useful way to try and get clear on what we're actually committed to ethically and what we should be committed to. You have thought experiments about brain transplants and various other ethical dilemmas aside from trolley problems. So the Chinese Room example is a thought experiment, and it goes like this. So Searle imagines that you are trapped in a room, so you don't have any way to get in or to get out or to communicate with people on the outside except via information that's passed into the room and then information you can pass out of the room. So in particular, the way it works is there's an input slot in which you receive messages that are written in Chinese characters, and there's an output slot for you to respond with messages that are also written in Chinese characters. The problem is, in this scenario, you do not know the Chinese language. So if you do happen to know Chinese, then just pick a different language. It doesn't matter which one we imagine. Searle just wants to use Chinese here because he imagines most of his readers, especially when he wrote this, would be native English speakers, and he wanted a language that would be quite different and hard to recognize for people who were familiar with English or similar languages. So for example, you wouldn't want to choose German or French because even if you don't know those languages, knowing English, you might be able to puzzle bits out about it using your knowledge of English. So pick some language that you know nothing about that's very different from the languages you do know something about. For many of us, that might be Chinese, but perhaps not for you. So in that case, choose a different one. So the issue here is that the room contains an instruction book that is written in English that you can understand and read that tells you how to manipulate the symbols. So it tells you how to respond to certain strings of characters. So for example, the book might say, if you get this, and then it gives you a picture of the string of Chinese characters, then respond with this, and it gives you another string of characters. Now you have no idea what the characters actually mean, but you can use this instruction book to give so-called answers to perhaps the questions that are being passed into you through the input slot. So you get let's say it's a question that somebody on the outside wrote, they slid into the room, you look at it, you have no idea what it means, but the instruction booklet in English tells you when you get precisely this, and there's a picture of these characters, respond with this, and then you have a picture of some other characters. So you write those down, you just copy the figures, pass them out the output slot. Now people on the outside may soon get the impression that they're communicating with someone on the inside who's actually fluent in Chinese, because from their perspective, they seem to be getting coherent, sensible answers to their questions. For those of you who know about the Turing test, this is sort of a version of that. The idea being that some people think a test for strong artificial intelligence would be that if you have an AI that can reliably trick people into thinking that they're communicating with an actual natural intelligence, so a human being, then it has passed the test. So this is a case where you might say, on the inside, it looks like, yeah, there's an intelligent person who understands Chinese on the inside because they're answering my questions. But in reality, we know that you don't understand Chinese. You're just very good at faking it because you have this very effective book written in English that tells you how to manipulate the symbols. So here's a bit of a picture of how it might work. You can see we have the input slot, call that a question. You on the inside, or whoever it is on the inside, grabs that question, looks up how to respond to that in the booklet. They write down that answer and put it on the output slot. The person on the outside will think, wow, this is a really sensible answer to my question. I must be communicating with someone who is fluent in the language. So Searle thinks this is a good analogy with computer programs. So computer programs, including so-called artificial intelligence programs, think in the same way, according to Searle, as the person inside the room thinks. So each one, both the person who doesn't know Chinese and the AI program, takes input information and outputs new information. And this is done via instructions or programming. In the case of the person in the Chinese room, it's with that instruction booklet. In the case of an AI program, it's whatever its programming tells it to do in terms of building off new information, what we sometimes call learning, though Searle is going to say it's not genuine learning. The point for Searle is that neither the computer program nor the person inside the Chinese room understands the content of the information that they're manipulating. You have no idea what the symbols mean, and the computer program, the AI program in this case, has no concept of what the code that it's manipulating actually means, what it stands for or what it represents. So Searle makes this point by distinguishing between syntax and semantics. So syntax is, broadly speaking, the structure of something, whereas semantics is the content. So perhaps easiest to see this with grammar. So in the case of language and maybe thought in general, grammar provides the syntax or the structure, whereas the actual meaning of the terms that fits within that structure, so the meaning of the individual words and sentences as a whole, would be their semantic content. So basically, structure would be something like subject-verb, right? You can make it more complex. That's the structure. You can plug into that many different sentences, right? Like the cat runs. If you know what cat means and what run means, and you understand how to string those together, you have a concept of what it means for a cat to run, then you have an understanding of the semantics of that sentence. But if you don't know what the word cat means or what running means, then these are just foreign words to you. You see them written down. You may be able to recognize there's a structure, a subject and a verb, but you will not necessarily know, or in fact you won't know in this example, what those terms actually mean. So that'd be a case of where you got the syntax down, but you don't understand the semantic content. The sentence has no meaning for you simply because you don't know what the words mean. So an example of this, a famous one, comes from Noam Chomsky. He gives this sentence of colorless green ideas sleep furiously. This has a recognizable syntax. So there's a subject, ideas, there's a verb, sleep. We have adjectives and adverbs, colorless, green, furiously. So the syntax makes sense, right? There actually is a recognizable structure that would make sense in the English language. But when we look at the semantics of this sentence, it doesn't make any sense, right? Ideas can't have color. If they could, then they couldn't be both green and colorless. That makes no sense. Ideas aren't the sorts of things that are capable of sleep, and sleeping is not the sort of thing you can do in a furious way. Metaphorically, perhaps, but not literally. So an example like this helps make Searle's point that there are cases where we have a coherent syntax or structure, but we lack any semantic understanding, right? We can't make sense of the meaning of this sentence because it doesn't make sense from a semantic point of view, although the structure is perfectly fine from a syntactical point of view. So what are the implications of the thought experiment? So Searle thinks that the Chinese room thought experiment shows, or at least supports the idea, that computer programs do not really think, including AI programs. So Searle wrote this long before large language models were a thing, but I presume he would say that his Chinese room thought experiment applies to them just as much as any other computer program. And the reason for this is that AI programs are merely manipulating information without ever understanding it. Searle thinks genuine thinking requires comprehension of the semantic content of words and sentences, and this, he thinks most will agree, computer programs cannot have. They can just be very impressive and very deft when it comes to manipulating information in terms of plugging it into various structures with which it works, right? So the syntax of the programming language it's working in. But no matter how good it is at doing that, it's never going to have any conception of what the symbols that it's manipulating actually mean. So just as we wouldn't say that the person in the Chinese room understands the Chinese language, we wouldn't say that a computer program understands what it's doing in terms of the symbols it's manipulating. So one implication of this is that it seems that AI does not genuinely learn anything because it never actually understands what it's doing. Just as the person in the Chinese room never learns Chinese, even though they might get very good at manipulating the symbols according to the structure or the syntax given in the instructions in the booklet, they'll never know the language based off of just that. They don't understand it. Same way that computers do not understand the content of what they're actually doing. So Searle makes a few claims here that some of which he thinks are supported by the thought experiment that we've just looked at. So the first thing he takes for granted is that somehow brains cause minds. So he's not a dualist. He doesn't think that the mind is some non-physical thing that can exist separately from the brain. Somehow the brain, which is part of the body, gives rise to minds. So far that might be compatible with physicalism or some aspect or some version of dual aspect theory. Second, he makes the claim that syntax is not sufficient for semantics. So no matter how fancy your syntax is in terms of linguistics or computer programming language, that is just something totally separate. It's a different category from semantic understanding. So understanding the meaning of what it is that you're doing. So Searle says that's something separate. You can't get semantic understanding from syntax. You need both of them in order to have what he thinks should count as genuine thinking. Third, he claims that computer programs, at least as we understand them today, are purely syntactical. So that means, well, no matter how advanced they get, no matter how impressive the large language models, that complex syntax will never provide any semantic understanding. So computers will never get what it actually means when it comes to what they're saying. Minds, however, Searle thinks, have semantic content. That's the hallmark of a mind, that you actually understand what it is that you're doing. An example might be that fits with the Chinese room thought experiment. If you take an exam in physics or something and you've just memorized all the right answers and you write them down, but you have no idea what the answers actually mean, you might get an A on the exam because you gave the right answers, but you didn't actually learn anything, right? Because you have no clue what these weird words are that you're writing down. So Searle thinks to actually engage in real thinking, to have some kind of understanding, you need to know what it is that you're saying. You have to understand what you're saying, not just say it. So some other implications of the thought experiment. Let's skip ahead back here a bit. Excuse me. So finally, Searle's conclusion. So Searle thinks, given those claims that he just made, computer programs are not and can never be minds. Secondly, the way that brains cause minds cannot be the same way that programs produce their outputs. Third, anything that causes minds must have so-called causal powers that are equivalent to those of the brain. And fourth, anything that we build that can think must have causal powers at least equivalent to those of the brain. So why does he say these things? Well, first, computer programs can't be minds because they'll never have the semantic content that's necessary in order to have a mind. Secondly, he thinks that whatever it is that brains do to produce our minds, to produce our mental states, it cannot be the same as the way that programs produce their outputs. And the reason for that is simply that, remember, those programs are purely syntactical, and they can only give you outputs in which we still lack a semantic understanding. But minds do have semantic understanding, so brains need to be doing something different than what computer programs are doing in order to produce thought and genuine thinking. So let's move on to an issue of consciousness. So we might define consciousness as being aware. Thomas Nagel famously defines it as there being something it is like to be a thing. Sometimes philosophers use the term qualia to refer to this. So examples of qualia would be the way an apple tastes when you bite into it. The way that an apple tastes, that's a first-person subjective experience that you have. It's a sort of awareness that you have that nobody else can reproduce from the outside, right? So we can say as much as we want about the chemistry involved of biting into an apple and what happens to the taste buds and all the various things that's going on. All that's interesting, but that knowledge seems to be just separate from being aware of what it's like to actually bite into an apple. And the same goes for all sorts of mental states where we are aware or in which we have consciousness. Examples would be feeling afraid or being anxious or feeling pleasure or pain. These are things that feel a certain way to undergo them. So one question here is, does thinking in the genuine sense require consciousness? And you might think yes, because if we're going to understand semantic content, that already seems like it's a fundamentally conscious activity. You might say that if I'm not aware of things, if I'm not conscious of what I'm doing, then there's not going to be anything it's like for me to do those things. I would, in that case, just be like a computer that's getting inputs and then spitting out outputs according to the structure that I'm set up with, the syntactical structure that I have. An unconscious being like a computer then might be very good at producing information, but it will never be aware of what that information actually means. And if Searle's right that thinking requires a semantic understanding, that means that computers can never think, no matter how complex and advanced they become. So here are some further and final questions we might ask. So is Searle's argument a good one? One question with thought experiments is they are because they are unrealistic, they give us these situations where we're inclined to say one thing or another, that, for example, no, the person doesn't understand Chinese, but perhaps someone doesn't have that intuition. What if someone says, no, the person inside the room does understand Chinese, because all that matters is that they can successfully answer the questions, and they do. So why shouldn't that count as thinking? Well, Searle thinks that's implausible. He thinks most people will agree. But again, that's the nature of arguments that depend upon thought experiments. You're just relying on other people having the same intuition as you do. So if you agree with Searle that, yeah, it doesn't seem like the person inside the Chinese room thinks, then, or doesn't understand Chinese, then he has a good basis for getting you perhaps to go along with the rest of his argument. But if you don't share that thought right from the beginning, then his argument might not be very compelling, at least for you. We might ask, if computers can't think, on Searle's view, and can never think, is it possible that nonetheless we could build something else someday that wouldn't be a computer, but would be something artificial that could achieve genuine thinking? Searle seems to leave that possibility open. He seems to be skeptical of it, but he says, perhaps, but if we ever get to that point, the thing that we produce that will do that thinking, it won't be anything like a computer or what a computer does. It would have to be something else that, as far as I know, we haven't thought of yet. Maybe it's possible, but Searle's point he thinks will stand that computers and computer-like things are not capable of thinking because, by their very nature, they lack semantic content. And finally, you might ask, is Searle right in his suggestion that minds might require a biological basis? So in other words, do you need to have a squishy brain in order to be capable of thinking, or is it possible that thinking can happen by other means? So for example, something made of metal and silicon, could it actually think? Maybe, but Searle is skeptical because it's hard to see how a purely artificial being could achieve consciousness. And if I'm right in the suggestion that consciousness seems to be necessary in order to have semantic content, then it would seem to make artificial intelligence a non-starter. But those are open questions. Perhaps we'll discover something surprising in the future that will show that actually artificial things are capable of thought. That would be interesting. But if Searle's argument is a sound one, that thing will not be a computer or a computer-like entity. Okay, so thanks for listening. I'll talk to you next time. Bye.